Hi, everyone. My name is Caroline Griffin. I am Riot's Director of Operations. Welcome to the Riot Lunch and Learn series, the place where we feature all of Riot's partners. I am super excited to have Jesus Centenio from TIBCO Labs here with us to talk about the Project Air overview. Jesus is the Chief of Staff and Innovation Strategy for TIBCO Labs, so he's an expert, and he's also, this is a bonus, he's also going to be the season 3 opener of Riot's podcast, so stay tuned for that coming out soon. And he also will be the keynote speaker for Riot's IoT Demo Night on Monday, October 18th at the Raleigh Convention Center in partnership with All Things Open. So super exciting stuff. If you have not yet registered for All Things Open and or IoT Demo Night, I'll drop those links in the chat. So please make sure you're registered for that so you can see Jesus again. But that is not why you're here today. You're here to hear Jesus talk about Project Air from TIBCO Labs. Just a couple of quick reminders. This presentation is being recorded and will be posted to Riot's YouTube channel and posted to the meetup group where you registered for this event. And if you have any questions throughout the presentation, please do put those in the chat box and we will make sure they are answered at the end of Jesus's presentation. But without further ado, I will hand it over to Jesus. Thank you so much for being with us today.
Excellent. Thank you so much for that intro, Caroline. And very excited to be here. And I guess we can get started here. So as Caroline mentioned, today I'll be talking about a program that we have at TIBCO called TIBCO Labs, and one of the projects that we have under the program called Project Air. So let's acknowledge the confidentiality agreement here for a second, and then move on into the agenda. So we'll start with a labs intro. We'll start talking about edge computing from a TIBCO's point of view. Some of the use cases that we're seeing and how those use cases have impact on different areas across different verticals. We'll talk about, as I mentioned, Project Air. We'll do an overview of the project, covering also the architecture. We'll go into a demo of the project, and we'll close with some references and resources to share with the group here. So just a quick background on TIBCO in case that you're not familiar with TIBCO. TIBCO is a software company. We've been in the market for decades, really, a large number of years. And, the easiest way to understand what we do is by grouping functionality and capabilities that we have across what we call pillars. And, we have 3 main pillars. We have the Connect, Unify, and Predict. And, self-explanatory, right? Like the Connect part of the portfolio is, capabilities that help you to pretty much connect to any system platform that you have, connect to the data and extract the data and do interesting things with the data, right? Like data movement, data management, MDM. And then, once you have that connectivity and data movement, then you move into the Unify aspects of the platform. So things like data virtualization, a way to understand common taxonomies and start doing the mapping of the data that is relevant to the business. And then the third pillar is the predict side of the house. So analytics, machine learning, predictive analytics, things like edge computing, for example, fall in this predict pillar. So most of the conversation today will be focused on this third pillar, but certainly some of the capabilities of the project go across different pillars in TIBCO. So I mentioned TIBCO Labs. TIBCO Labs is an innovation program that is sponsored by the Office of the CTO and the CAO at TIBCO. And the main goal of the program is to basically incorporate different areas of innovation in TIBCO's portfolio. So, as we talk to different customers from different verticals with a wide range of type of use cases, oftentimes there's areas of technology that they may not have a direct mapping into TIBCO products. And TIBCO Labs program is a very interesting and exciting way to address those areas of opportunity for us. So focusing on different type of technologies, things like blockchain, AI, ML, IoT, of course, that we're going to be talking about today, but within IoT, things like computer vision, for example, augmented reality, NLP, graph database development. So, completely different areas of technology, but then they are equally important to a number of customers on our end. So the easiest way to understand then the taxonomy of TIBCO Labs is by understanding that we group these areas of research and development under what we call projects. And we have about 10 or 12 active projects. On the screen there's examples of some of them. So for example, starting on the top, we have something called Cloud Composer. That is a framework and a toolkit that allows you to create web application or develop web applications, and easily incorporating different services or capabilities from other areas of TIBCO's portfolio, and deploy very quickly, very easily those applications into TIBCO Cloud and have business users consume those capabilities. It goes from that to all the way to, as I mentioned, right, things like, for example, augmented reality with Project Art, as an easy way to incorporate information or messages from different platforms across the enterprise and have that data enrich an augmented reality experience leveraging AR devices. Today, the main focus will be, as I mentioned, on Edge Analytics, and that is Project Air. So let's get us to start talking about this subject area. When it comes to Edge Analytics, TIBCO has a long history around this, right? All the way from early days, IoT plain vanilla scenarios, right, to much more compelling use cases in today's world. So things like digital twins or crossovers between computer vision and augmented reality. And we have a number of different customers with super interesting stories, right? So one of my favorite ones, me being a Formula One fan, is our story with Mercedes Petronas team on Formula One, and basically how they leverage IoT technologies to create a digital twin, a digital representation of the car, and do a lot of simulation-based scenarios, right? So from testing new capabilities, understanding the performance of the car, or even measuring the performance in real time once the car is on the track, right? So for Formula One drivers, one of the main challenges is that it's not that the car is on the track 24/7 and you can always test and you can make changes in configuration in seconds, right, and test again. All these things, they are very hard to do and very expensive to do, right? So leveraging digital twin concept in that sense, incorporating feeds from IoT sensors and gateways to enrich the quality of that digital twin representation of the car is extremely important, right? It's a game changer for this type of scenarios. So the real question, right, as I mentioned, right, for us, edge computing overall is pretty horizontal, right? So for us, most of the time the question is, what happens in the end with the data, right? And the data that is being generated at the edge, and how is it being consumed? How is it being leveraged? Is it being done efficiently or not? How the edge in the end is integrated with the rest of the enterprise, right? And those operational systems or transactional systems in the rest of the enterprise could be 100% on premise, could be in the cloud, could be a hybrid scenario, right? So all these different combinations of permutations are going to drive a number of different challenges, right, when it comes to the integration aspect of edge computing. So when we come to real life scenarios, right, what we end up finding, right, is the edge can look totally different, right? That's also part of the complexity here, that what the edge is for a manufacturing plant is going to be totally different to a transportation company or a supply chain company or a fleet management company, right? So but typically, you know, when we talk about the edge, we mean a picture kind of like what we have here on the screen, right? So, yeah, a lot of different components, a lot of different, you know, let's call it stuff, right? Moving all over the place, right? And whether there's physical boundaries or not on you know, all these components, right? Or is kind of like loosely defined over a large, larger network or territory. That's what in the end we call the edge, right? So it's comprised of a collection of sensors and gateways and devices, right? That they're going to be transmitting data and they're going to be interacting amongst themselves in many cases. And you know, in many other cases, they're going to be fully automated, right? Including how to respond to specific events that they're happening or taking place at the edge directly, right? So that when we talk about that and you know what it means in terms of like technical requirements, you know, there's different aspects, right, that they need to be fully acknowledged here. So you may get the question, right, from even your customers or your users or your stakeholders is, well, yeah, everybody talks about edge, right, and edge computing, but why edge computing, right? Like, I mean, why? What's really the big deal about edge computing versus cloud computing, for example, right? And when we start thinking in terms of you know, the value that the edge brings to the table, right? Like the answer becomes fairly self-explanatory, right? So when you rely heavily just 100% on cloud computing, you're talking about, you know, a lot of data movement, transporting data. That on its own will come with a certain degree of latency. And obviously, you know, a lot of different type of security questions and concerns that they may come up as well. And then also, you know, figuring out not just the way you get to the cloud, but also back, right? Like how you then do analytics or, you know, whatever it is, really like something like, you know, machine learning for a prediction, right? Or an inferencing on a picture, for example, right? And then sending the output of that processing, right, to the edge to take a further action. So that back and forth, you know, in many cases, it can be extremely costly to do, right? So that's when edge computing really, you know, becomes super key and enabler and requirement of the solution, right? So with edge computing, then you can move a lot of that processing and analytical capabilities to the edge. So the decisions can be, or the processing can be done directly there at the device level. And the action can be also enforced immediately. So, oops. Oh yeah, well here, sorry, like I think I was speaking too fast, but you know, just to summarize, so some of the key points that should be considered when we talk about then edge computing based solutions are things like, you know, how are you going to then scale, right? So if you have, let's say, an environment with 10 devices or 10 sensors, is not the same as if you have like 1,000 sensors, right? Or 10,000 sensors, right? So the question on, you know, how you build a platform that can go from 10 to 100 to 1,000 to 10,000 as needed and as fast as the demand, as the business side demands, it's definitely something to be considered. The reliability that you need to have is also quite important, right? So typically when you talk about like cloud computing, you have a lot of failover capabilities, right, that are there to support you know, any particular events or you know, can allow you to recover from a particular disaster. When you're talking about the edge, those requirements, right, like are still relevant and they still need to be addressed, but at the edge itself, right? So if it's going to be, you know, a way to do batches of data going from the device itself to the cloud to be backed up, or if it's going to be a local storage on the device itself, you know, those are the type of questions that you need to make sure you go through them. And then, you know, performance is absolutely key, right? So, you know, the whole goal of going with edge computing versus cloud computing is, you know, to gain performance, right? Like the speed to value, the speed to get to a quicker decision much faster, right? And if you think about it, when we talk about edge computing, right, or edge-based solutions, you're talking about transactions that take a millisecond, right, and then you need to react, or you need to identify if there's an anomaly that needs to be addressed in that transaction right there on the spot, right, and take immediate action, right. So that's really the whole aspect of performance in the solution. And then last but not least, keeping an eye on making sure that you materialize the gains that you're going to have on efficiency in your business process. So same scenario, right? When you take decisions, or when you identify anomalies in milliseconds, right, that allows you to respond right there on the spot to a particular event. So when it comes to, let's say, customer interactions, that allows you to have much better ways to interact with customers and have that as part of the value proposition of the customer experience that you can offer. So when we start then looking at the edge computing ecosystem, right, and if you sometimes go through this exercise yourselves to basically understand where your business or your organization falls in the ecosystem, one thing to understand is that it's an extremely crowded ecosystem, right? There's and very segmented, right? So there's companies that they may have just one area of focus overall. There's companies that they may have they go across different aspects of an end-to-end solution. So when you think of building or having an end-to-end edge computing platform, making sure that you address the requirements coming from each one of these areas, it's quite important, right? And if you have a platform that can address requirements across most of the areas, it's even more relevant, right? So in the case of TIBCO, the way we enter the space, right, is in a couple of different ways, right? So we play very well with industry specific players, right? So project care is something that can be positioned in the context of any industry, and it can be basically customized, right, to address specific use cases on a specific vertical. So we play very well with industry specific solutions, right? We also play very well with system integrators, right? So when you have an edge computing platform that is part of something much larger, maybe like a supply chain system, right, that has edge computing components, right? Project Care is easily embedded into larger ecosystem, right? We play very well in scenarios where you may have the need to have like a multi-tenant approach to edge computing, right? Like if you have if you need edge computing capabilities, not just for your own business, but like for your customers' businesses as well, and then you want to have or you want to create a managed services, sort of speak, platform, right? So Project Care fits very nicely into those scenarios as well. And last but not least, as we'll see, anything that has to do with device management, the ability to map your IoT ecosystem, understand all the different taxonomies, all the different interfaces per device, and how to connect to each device, how to extract the data, and how to standardize or normalize that different taxonomies, right, into a unified way of understanding the IoT data. That's something that Project Care does also very, very well. And when you put all together, right, it's not just the data flow, right, like from edge to enterprise, but also the ability to send, again, right, as I mentioned before, analytical capabilities to the edge, right? So being able to orchestrate everything around machine learning, the ML ops cycle at the edge, and be able to leverage predictive analytics for a number of different use cases, right? So translating what I just said into specific examples, right? So it can go in so many different directions. For us, it really, the conversation really depends on the vertical in question. And once we have that vertical, right, like we go deep into some of these use cases, right? But across the board, things like, predictive maintenance, for example, or error classification applications for manufacturing, Smart metering for smart city, scenarios as well. We do very well. Anything around, telemetry, right? Like the track and trace capabilities across complex supply chains, as I mentioned before. Including, for example, connected vehicles or IoT wearables as well. That's something that we do. And in general, right, the automation concept, right? So let me play a video really quickly for you on Project Air. So this will set the context on before we jump into the specifics of Project Air. So
your organization needs to be more agile and responsive than ever before. It needs to rapidly respond to fluctuating market conditions and make faster, smarter decisions to provide your customers with the best possible experience. Organizations in all industries are heavily investing in technology, including cloud, data lakes, and analytics. But this is not enough. To make timely, relevant, and contextual decisions, an organization must extend its reach with IoT and edge computing capabilities. With edge computing, you can collect more valuable data and use advanced analytics to make the edge smarter. You can collect higher quality data, optimize data movement, and increase your ability to transform IoT data into actionable insights. From supply chain asset tracking to industrial predictive maintenance, from healthcare anomaly detection to smart city robotics, edge computing enables new capabilities. And when edge computing is combined with technologies such as data streaming, real-time analytics, and computer vision, more complex problems can be solved. For example, edge computing may be used to customize the customer experience at the point of interaction, closely monitor equipment and workers to ensure safe operations, and optimize supply chain processes. However, developing edge computing solutions can be challenging. Seamlessly integrating several hardware and software systems is required. Data streams need to be processed in real time and include advanced analytics in various forms, including image processing, video analytics, or models built in languages such as Python. And all of this needs to be done securely against potentially hundreds or even thousands of devices. TIBCO Labs is working to make edge computing accessible to organizations like yours. Through its open source initiative, Project Air, TIBCO Labs provides an end-to-end blueprint for edge computing solutions that makes data collection, data pipelining, machine learning model orchestration, video inferencing, and other capabilities easier to implement and deploy. All while keeping you free from vendor lock-in and leveraging the power of the open source community. Want to get in front? Interested in learning more about TIBCO Labs and Project Air? Get the conversation started today.
okay, perfect. Yeah. So hopefully that gives you a good preview on really what Project Air is all about, right? So easiest way to understand it, right? Think of Project Air as a platform that, as you may recall from the first slide that I shared, right? Like the 3 pillars, right? It starts with the connect aspect, right? Like this platform allows you to connect to your IoT environment, to your IoT ecosystem, map a large number of devices and wide range of devices. Understanding the taxonomy of each one of these devices, allowing you to select the interface from each device and doing any calculations that are needed as you build the data pipeline from the device to where the data needs to go to be at rest. So that data being at rest in the end can happen whether it's in the cloud or enterprise or hybrid scenario. It could be both. As we build those data pipelines, right? You process the IoT data and you always stay in control and in ownership of the data, right? So as opposed to other platforms that may lock you out of the data, right? With Project Air, you're always in control of your data. You're always in ownership of the data. The platform itself can be deployed on any cloud environment. So, cloud agnostic in that sense, and very easily extendable in every layer, right? So whether it's at the device layer or the connectivity layer or the analytics aspect of the solution, right? Like each one of these layers can be extended in different ways. So let me go here to the next slide. Okay, yeah. So, the value prop in the end for Project Air, right, ends up being the ability to register, interact, do the data pipelining, process the data in any way that is needed, and then bring the analytical components at the edge, right? So the ML aspect of that I mentioned before, being able to deploy ML models and do the orchestration of the models. So meaning, if you are building different pipelines and each pipeline comes from a different type of IoT device, being able to select the type of model that is going to apply to that pipeline and how it's going to be applied, right? So you can do a simple prediction on, let's say, a temperature reading or a pressure reading. And if a threshold is not met, right, then take immediate action on the device itself, right? Like whether it is increasing the or decreasing the temperature on the AC, for example, or shutting off a valve to reduce the pressure, right? As simple as that, or as complex as you have cameras as IoT devices, and then you're getting streams of video, and you want to do the inferencing in the video itself to determine if a particular condition is being met and take action upon that event, right? So it's a number of different things, but that aspect of ML ops at the edge is another key aspect of the solution. So if you're gonna walk away with one, I guess, slide in your mind, probably this could be the best one for that, right? As a way to summarize then all the different capabilities that we've been talking about, right? So the connection, the extraction, the management of the pipelines, the creation of triggers to have real-time way to respond to IoT events. So whether it's business rules or reading based, right? But just basically having triggers to detect those scenarios and take immediate action. The bringing the data to at-rest repositories, wherever the repositories may be, and then connecting that with analytics, right? So as I mentioned, right, like the third pillar for us, right, the predict side of the house comes with a very robust set of analytical tools to do historical analysis on IoT data, real-time analysis, both, right? Or, embed, for example, machine learning models to do that historical analysis on the data as well, right? And then, the console allows you to monitor and do basically, an easy way, a centralized way to look at your IoT ecosystem in one screen and understand, the status of all the different pipelines that are defined. And then the ML ops aspect of the solution that we've talked about already. So now when you look at the structure for Project Care, right? Like one key component at the core is an open source framework that we use. It's called Edgex Foundry. I'm guessing that some of you have heard about it, or you're familiar with it probably. But for us, Edgex Foundry is a key component of the solution, right? And this is the framework that organizations like Intel, HP, IBM, Accenture, right? Like, I mean, they have based their IoT strategy on this framework as well, right? So for us, it's very easy to then go into the ecosystem and collaborate with other organizations that they have the same common denominator as we do, right? The framework itself is highly extensible, as I mentioned, right? It allows you to extend, in any of these layers. And easily, for example, leverage, the connectivity aspect of the framework, right, to connect to different type of devices and funnel the data through the framework. So to start giving you a pictorial view, right, on where exactly Project Care then ends up fitting in the organization. As I mentioned, Project Care fills the gap for the IoT platform in your environment, where some of the deployments of Air can be deployed in the cloud or on-premise, and some other components will be deployed at the edge as well. So, thinking in terms of giving you a high-level architecture view on the project itself, right? So, starting from the left, think of this blue box as your IoT ecosystem, right? So whatever you have going on there, whether it is sensors, devices, wearables, cameras, gateways, mobile devices, right? Like, whatever the case it is, right? For us, this blue box ends up being, not like a black box necessarily, right? But for us, this blue box can look in any way, right, that the customer needs. Our main point of entry ends up being the IoT Gateway. So think of the gateway as the way of centralizing or funneling some of the data, right? So for example, in manufacturing, you may have a gateway on the production line that is aggregating or capturing the data from the 10 sensors that you may have on the production line, right? Whether it's sensors that measure the color, the temperature, the pressure, the size, the whatever it is, right? On those on those things that are being manufactured. But on this gateway, this is where we deploy components of Project Care that allows us to create the pipelines to transport the data from the gateway to the enterprise. In Project Care, as I mentioned, right, like we do also the ML orchestration aspect of the solution, right? So you can deploy, models, anything that can be containerized and can be then deployed to the gateway, right? And the gateway in the end can run. We can handle through Project Care as well. From a data pipelining point of view, once you define the pipelines, then basically we stream the data along the way, right? And as we stream the data, as I mentioned before, you can define the business rules that you need. You need the alerts that you need in order to respond to IoT events in real time, right? So once a condition is met, then you can pass an action that is being executed on the device itself. For us, I've been talking about computer vision, right, and how Edgex is a common denominator that allows us to interact with other players in the space. So computer vision for us is a great example of that, right? At the core of Project Care, I mentioned we have Edgex Foundry, that is a framework from the Linux Foundation. We use another framework from TIBCO that is called Flogo. And Flogo is a framework that allows us to create a microservices-based architecture, right? Lightweight microservices that can be deployed at the edge and can be leveraged for the execution of the pipelines. Now, having this common denominator through Edgex with Intel allows us to incorporate frameworks from their ecosystem. That is the example of Video Analytics Serving, VAS. This is a framework, open source framework that Intel developed for the processing of images at the edge. So what we do is, we incorporate VAS that, is compatible with Edgex. And with that, we can now have also computer vision capabilities as part of Project Care. So this is a good example, right, in terms of, as I mentioned, the extensibility aspect of Project Care. How we can expand it, leveraging not necessarily just typical on frameworks, but other frameworks from other players in the space as well. So with computer vision, what we've done is that in collaboration with Intel, we've created a number of horizontal capabilities. So these capabilities allows us to do the real-time streaming of data, as I mentioned, right? So whether it's computer vision based on static images and then doing the inferencing of the image itself at a time, or doing the inferencing on streams of video as well, right? So, classic example is maybe the concatenation of these inferencing models, right? Like if you want to see, for example, read the plate number of trailers on a highway, first you would need a model that would read, could identify the trailers versus cars. And then once you have the image of the trailer, then another model that identifies the plates on the trailer itself. And then once you have the plate, or the frame that represents the plate itself, then another model that actually reads or understands the digits and letters on the plate, right? So that concatenation of different streams of data or different images. When in the example that I just mentioned, right, when we talk about inferencing, we're talking about different machine learning models or different models that are intended to do different things, that they are concatenated and using in conjunction to come up with a desired output. So with computer vision, what we've done is we've gone to specific industries or specific verticals and look at either new use cases or traditional use cases that have been done in the past, maybe different, but now with computer vision capabilities can be done much better, right? So on the screen, there's an example or a sample of those use cases specific for retail, for example, right? So self-checkout and loss prevention, it's a very good use case for us because it incorporates another concept that we refer to it as sensor fusion, and is this idea of, you know, in a more like a real life scenario, right? When you have IoT based solutions, oftentimes you're going to need to take the input from different sensors and be analyzed not just in real time, but together in real time, in order to determine if there's really an anomaly or not, right? So in the case of loss prevention, for example, think of you know, a point of sale kiosk, right? Like a self-checkout kiosk at something like, you know, like a Walmart or a Target, right? Where in that station, you're going to have at least like 3 or 4 things going on at the same time, right? You're going to have probably a scanner that is going to read the SKU of the product. You may have an RFID mat on the station itself that is going to read, you know, it's going to get a reading from an RFID sensor on the product itself. You're going to have also a scale that is going to measure the weight of the product, and you're going to have also a camera that is going to be taking snapshots or images of the product that you're scanning, right? So the classic example here is if you may have, let's say, a gallon of milk, and you scan the gallon of milk, but then you're not putting the bottle of wine in the cart, right? That's going to be a problem, or should be a problem, right? Should be flagged as a anomaly. And you know, in that case, the process is to stop, right? And then human intervention is trigger, you know, to resolve the problem at the station itself, right? So, you know, if you think about it, in those cases, it's really the combination of all those 4 sensors that is going to detect, you know, some of these anomalies, right? So that's a great example on how you know, for us, computer vision, you know, rarely is a capability that is kind of like standalone, right? Like it's more often used in combination with other things coming from the edge as well, right? So but in addition to that one, we have things like another interesting one, number 4 there, the smart drive-through, where you can have, for example, in the fast food industry, where you have drive-throughs and cameras on the drive-through, you know, the inferencing of the images coming from those cameras is going to allow you to understand, you know, how many cars you have in the queue, what kind of cars, how many people you have in the cars, you know, the approximate ages, right? Like kids versus adults, for example. You know, demographics, right? Things like, you know, female versus male, for example. If, for example, some of the customers, while they are in the queue, they are already interacting with the customer loyalty application, right? And using the Wi-Fi of the restaurant. You know, now you just don't know all that information, but you also know who exactly they are, right? And what they typically order, and you know, all these capabilities in real time, they allow you to respond much better, especially during peak times, in terms of what is going to be ordered or needed in the next 5-10 minutes, right? So kind of like get ahead of the curve and start, you know, the food preparation before even the order happens. Okay, we talk about loss prevention. So let me go into a demo. I want to go to the demo and then leave a little bit of time at the end for Q&A. So for the demo, I have one of my colleagues, Marcelo Gallardo, is going to be conducting the demo. Thank you.
Hello, my name is Marcelo Gallardo. I am a member of TIBCO Labs group. In this demonstration, we are going to show how to put your business processes for IoT devices as close to the data as possible. The demo will simulate a point-of-sale station that includes sensors like scales, scanners, and computer vision virtual sensors. The data from these devices is fed into the Edgex framework where data is standardized for consumption by Project Air pipelines. Project Air data pipelines feature interaction with data coming from regular sensors and also data coming from BAS, which is a video analytics serving framework. The pipelines are deployed to the edge, but could have also been deployed to your cloud infrastructure of choice. All depends on the requirements at hand. Let's get started by first looking at the simulator, and then we will show how we build the solution. In this simulator, we have presented the different sensors with some simple visualization. The user actions simulate real sensor readings. Here we will simulate a happy path scenario, and then we will simulate a loss detection scenario. The table at the right will display the warnings or errors generated by the data flows to indicate invalid or suspicious events that can be presented to the client or advised to the personnel monitoring the POS stations. First, we will simulate the happy path scenario. In this case, we simulate a user scanning his ID to open the basket by clicking the ID icon. We receive a notification that the basket has been opened. After that, we simulate an item being put on the scale by clicking on the scale and selecting the item that was placed. In this case, we will simulate the raffles. And we weigh the item, and we can see the weight is 0.81 pounds. After that, we are going to simulate the item being scanned on the scanner. We click on the scanner and select the item to be scanned. In this case, since this is a happy path, we are going to select the raffles item and scan the item, and we can see the raffles is shown on the screen. The next step is to place the item on the bagging bag, and so we are going to simulate the picture being taken by the camera when the item is placed on the bag. So we'll select the raffles and take the snapshot, and we can see that the item has been placed on the bagging area. Finally, we're going to simulate the payment by clicking on the credit card icon, and then we close the session by clicking on the basket close. After we are completed, we can refresh the notifications table, and we can see that there's nothing on the table, which indicates that everything went without any issues. Now we will run a few scenarios with unexpected patterns that might indicate fraudulent activity, and how the system will be able to provide advisories for the users as well as for the personnel monitoring the stations. Let's start by a client coming to the station and opening the basket. So we get a notification success. We check if there's been any warning on the notifications. We refresh and there's nothing there. So now let's say that the user comes and picks an item and tries to scan it. The normal sequence is for the user to come and put the item on the scale. So let's try scanning. Let's select an item. So in this case, we're going to select the Mountain Dew item. We scan it. The item is scanned, but let's check the notification window. And here we receive an error saying that the product has not been scaled. So in this case, we will notify the user that the item needs to be scaled first. So the user received the notification. So he goes to the scale, and now he put the item on the scale, and he weighs the item. So the item is weighing 469. Let's check if there's any notifications. Nothing there. And now let's say the client tries to scan the item again. We select the scanner, but let's say this time the user is trying to scan a different item than what he placed on the scale. So let's say now it tries to scale the raffles, and we scan the item. Again, let's check the notifications, and we can see there's another error, and it says product weight not matching. So the user is given a notification saying that to select the right item. So we go back to the scanner, and now we scan the right item, the one that was weighted. Scan the item, and the event was sent. So let's check the refresh activity, and the product says not scaled yet. So since the sequence was not followed correctly, so we have to come back to the scale and select the Mountain Dew again, weigh the item. Let's check if there's any notifications. No notifications. Let's scan the item. Let's scan it correctly this time. Let's select the Mountain Dew, scan the item. Let's check the notifications, and we see there's no notifications. Now we can proceed to the next step, and let's say that the user is going to place the item on the back, but he placed the wrong item. So let's say he placed on the basket the Kool-Aid instead of the Mountain Dew. Test the snapshot. The event was sent through a photo that was taken to a model that identified the object. And let's say what do we get here, and says item is not matched. So the user will be notified to select the right item to place on the basket. So we will simulate again, and now we will place the right item, the Mountain Dew. Let's say if there's any notification. There's no notifications at this time. So at this time the user can submit the payment and close the basket, and the transaction is completed. We refresh again the notifications, and we can see that there's no more notifications. Now that we have seen the simulation, let's quickly review how we achieve this. First, we go to Project Air's overview page and select the group of devices we want to work with, in this case the POS station. By clicking on the View Details link, it will take us to a page with a list of all the devices in this group, and also the list of sensors associated with the devices. If we click on a specific sensor, we are presented with a list of events that have been emitted by the device. Going back to the overview page, we can select the pipeline editor by clicking on the pipeline icon. This will take us to a page with a list of all the different flows that have previously been created and deployed and are actually running. So if we click here on the POS station pipe, we can see the flow that is consuming the data from this device. So here we can quickly review. We have a data source which was configured to receive data from the Edgex protocol. Then we call a REST service that was implemented using Flogo user interface. So here we're just calling that service. We configure the URL for the service, and also we select the list of devices, the data that we want to send to that service. The results of this service are being sent to a data pipe, which is the Air data store pipe. So because we want to save the events for Air to visualize, and also we are sending the results to a notification service. That's pretty much the logic we implemented on the simulation. If we want to see how to create this pipeline, we can simply create a new pipeline, select the activities by clicking on the right button. We can select the data source, select the protocol, in this case the HMQTT. The next activity is the Flogo service. We click on the REST service, connect the activities, and configure the REST service. Here we're going to paste the URL, which will give it a test, and we can select the devices, the data for the device that we want to send to the service. Next, we want to configure the pipeline, the pipe that where we want to send this data, the results. In this case, we want to send to the Air data store, and we select Air channel. And then the next thing is we want to send a notification, the results to notification service. We configure the notification and select the protocol. That's all is needed for this, and we can give it a name, test pipe. The type is a type edge because we want to deploy to the edge, and give it a description. Once that is done, we can save the pipeline, and it will show in our table. And now it's ready. You can see the status is saved and is ready to be deployed. That concludes the demonstration. And if you have any questions, please feel free to contact us. Thank you.
All right, excellent. Yep. So to do a quick recap here, as we just saw in the demonstration, right? Like Project Air being one of the first really no code platforms to do IoT and edge analytics development. So there's plenty of references and resources that I want to share with the group. If you want to learn more about, for example, what we've done with Intel and computer vision, we have a website. There's a solution overview that you can download from the website. There's a number of recordings available with other type of demos and stories that you can watch as well at your own time and your own pace. There's, for example, a recording that we did earlier this year during open source event that we did. And last but not least, there's a GitHub repository where you can get all the documentation and you can actually download Project Air and get started with a local install of Project Air as well, if you want to start playing with it. And there's the TIBCO Labs website on the top, where you can read more about Project Air, as well as some of the other projects that I mentioned at the beginning. If you want to get a hold of the TIBCO Labs group, this is ways to do it over email with the tibcolabs@tibco.com email address. And as I mentioned, right, like YouTube playlist, go for search for TIBCO Labs and you get a number of resources there available as well. Something super exciting coming up on our end. We have the first global hackathon that is going to be sponsored by TIBCO and the Office of the CTO. It's going to be based on Project Air. Great opportunity to collaborate with some of your colleagues, learn more about Project Air, develop real life prototypes of solutions, and also have a chance to make some money. Right, so great prizes, $10,000 for the first prize, then $5,000 second prize, and third prize $2,500. There's also opportunity to make even a little bit more through some of the special prizes that we'll have, special awards that we'll have for the hackathon. So the hackathon itself will start on November 15, and we'll go through an ideation phase first. And then, we'll have a selection of the best ideas, and then that will get us into the core of the hackathon from January 24th to January 31st. And then the winners will be announced on February 3rd. So the registration page will go live at the end of October. And the easiest way to keep track of the progress on the page and the hackathon overall is hashtag OSSDayHack, or also feel free to connect with me on LinkedIn, and I'll be posting a lot about the hackathon as well. So once we have the page, definitely I'll publish it on LinkedIn as well. And as far as upcoming events, the next one that we have coming up is the All Things Open conference, as we said at the beginning of this session. I'll be co-presenting there with Intel. So in that session, we'll go deeper on the integration with VAS and how it can be leveraged for computer vision. And we'll also be part of the Riot IoT Demo Night on Monday 18. So if you're going to be there, feel free to stop by, say hi, and we can chat more about Project Air for sure. So with that, let me open the mics here to see if there's any questions. I haven't followed the chat window, but let me see if there's anything in here, or if you have any questions, feel free to just go off mute and ask the question.
Thanks so much, Jesus. Yeah, I don't see any questions in the chat box, but as Jesus mentioned, please feel free to unmute yourself and ask live.
Hey, Jesus. It's Chris Hayes here. Hey, I was wondering, I really like the presentation, the solution there. I was looking at that. You had mentioned automation in there a few times. It looked like, the tool itself, right, was walking us through building out this process. Do you guys have any ability to automate that once, if you will, the process is defined? And so typically, how do you guys address that? Or is it primarily a manual type of solution where you have an operator that would, facilitate some of these things in the back end through monitoring and so forth?
Yeah. Great question. Yeah. So, as you can imagine, this is the kind of project that keeps expanding, right, in terms of depth and scope, almost every week, right? So one of the areas that we're looking at right now is the ability to automate the deployment of the infrastructure piece of Project Air. So we are looking at the integration with Open Horizon framework, and leveraging Open Horizon to deploy the Air components that are needed at the edge, for example, right? So the scenario would be like if you have, let's say, your Target, for example, right? You're going to open a new store. you need 50, 100 cameras on the store, all configured the same way. Kind of like auto detect the cameras, right, and push out the same configuration throughout the batch of cameras. Being able to do that with a couple of clicks from Project Care, right? Like that's really the use case that we're looking at. I think though you're referring to the automation of the pipeline itself, right? Like the creation of the pipeline. And we don't have that in Project Care today, right? Like so the pipeline is something that typically you would create a pipeline at a time, right? I can see how it would make sense for that scenario, right? Like you're deploying 50 cameras, you want to configure the 50 cameras the same way, and you want to like apply or have the same definition of the pipeline across the 50 cameras, right? As a kind of like a next step for us after the initial expansion that I just mentioned.
Right, very good.
Yeah,
that'd be interesting.
Good feedback. Thank you. Yeah, that's good feedback.
Perhaps I'll see you at the IoT demo night. Talk some more.
Excellent. Sure thing. Yeah, looking forward to it. Yep.
Thanks, Chris. Thanks, Jesus. We'll leave it open for another minute to see if anyone else has additional questions. All right, I think we're good. As mentioned earlier, this presentation was recorded. It'll be posted right at YouTube channel and then shared via the meetup group where you registered. We hope to see you at All Things Open and IoT Demo Night on Monday, October 18th. Jesus will be our keynote speaker. We're super excited to have him. They'll also have a exhibit table in our exhibit hall. So for more information, please visit the link that I dropped in the chat, and I look forward to hopefully seeing you there. Thanks again, Jesus. Great presentation. Take care, everyone.
Excellent. Thank you. See you soon. Bye.